Pull the door closed at the back, I'd appreciate it, thank you. Okay, my name's Joe Allnut. I'm here to talk to you about GeoGig. I'll say up front, I'm not a contributor to GeoGig. I've not been involved in making the GeoGig software. I'm just someone who's tried using it, and I'm going to share some of my experiences with you today. So a quick overview of what I'm going to take you through. First of all, a quick introduction to myself and the organisation I work for. That's Ordnance Survey. I'm then going to do a little section on what Git is and what's so good about it. Hands up who knows what Git is. Yeah, that's quite a high percentage. Hands up who knows why it's so good. That's slightly less. Hands up who just uses it because everyone uses it and it must be brilliant. Yeah, that's where I am. Okay, so I'm going to talk a little bit about some of the things that make Git good. And then I'm going to talk about what GeoGig is, a little bit about how you might use GeoGig, because it can be fairly basic, fairly concise compared to the big workshop that was on Monday that some of you may have been to. I certainly went to it. Then I'm going to attempt not one, but two demos. One demo of just showing you me putting some data into GeoGig on the command line. Everyone likes a command line demo, don't they? So that'll be good. And then another demo, I'm going to try and show you something of the QGIS plugin that's available for GeoGig. Yeah, so I'm going to talk about the plugin as well. Then once I've finished, I'm going to tell you about the conclusions that I made in my experiments with GeoGig. Okay. So first of all, I work for an organisation called the Ordnance Survey. It's a funny name, isn't it? Ordnance Survey. And that's because it was founded in 1791, and at the time, the equivalent of what's now the Ministry of Defence over in Great Britain was called the Ordnance Office, I think. So they were concerned with getting ordnance to the right parts of the country. They decided back then that there were lots of good reasons for having maps. Most of those good reasons involved fighting the French or the Scots or other people who we were at war with. So in 1791, which I understand is 15 years after the USA was founded, the Ordnance Survey was put together to start making maps of the south coast of Great Britain, so we'd know where the French were most likely to land and how to tackle them there. But things have moved on, and so have a couple of centuries. In that time, Ordnance Survey have been quite good at staying close to the front of technology in mapping, whatever that might be, from theodolites to web services. And my role at Ordnance Survey, and I've only been there 5 years, so hardly any time at all, really. My role at Ordnance Survey is I run a small team called Technology Labs. My team have a kind of fun job in that we get tasked with rapidly building prototypes and proof of concepts for various reasons. One of the most important reasons is to try out bits of software that are out there, bits of technology, and see if there's something that Ordnance Survey should be making more use of, or at least something we should be aware of, because it could affect our business. And it's probably worth me saying, actually, what Ordnance Survey's business is, and primarily it's providing really, really good geospatial data to the people in Great Britain that need really, really good spatial data. We have two sort of sides to the business. The side you guys would probably like more is the open data side. So government gives us some money, and with that we produce data and give that to the public, all of you, to use under suitable licenses. But also we make some data which we don't give away, and we sell that, and that's one of the ways we earn money to do the work that we do. At the moment we're a government-owned company, which means we're a company with one shareholder, and that's the government, and they decide how we're going to operate and what our business model should be. So that's all fun. As Technology Labs Manager, I had opportunity to sign up as part of Location Tech. You're all wearing the lanyards, so I imagine you know who Location Tech are. Andrea spoke about that on the opening day. And Location Tech is part of the Eclipse Foundation, and it's a really great place for me to be involved with, because I get to see all these fantastic projects going on, and it would be really good to try and get involved with them a bit more, hence me coming here and talking about GeoGig. GeoGig is just one of many Location Tech projects. They're all sort of geospatial, open source, so ideal for the people at this conference. If you go to locationtech.org, you can see all about them. Okay, so what is Git? So most of you said you know. I had to give this presentation to a non-technical group recently, and this was a challenging part of the presentation. So I've probably got more slides in here than I might need for this audience. One thing, the word Git is British slang. I don't know if it's American slang, but it's British slang, and it's not a very nice term to call someone. So I think the authors were aware of that when they chose it. But it's a term that you're not allowed to say in the House of Commons in Britain. You will be reprimanded, and if you don't apologise immediately, you'll be sent out of the House. But basically, I've written a little my version of what I think Git is for the layman. But you need to be able to have lots of people around the world collaborating on a piece of code. You need to have all those clever techniques of forking and merging and branching to make that a possibility. You want to try and avoid a single point of failure. You need to have that data distributed, and you can read all about this on the Git website. Fine. What is Git? So the guys writing the Linux kernel, they had this problem to solve. They couldn't use the software they were already using for various reasons. So they came up with Git. And they're pretty smart, the Linux kernel guys. I don't think I'm understating things there. And they came up with a really good system. And if it's so good, why doesn't everyone use it? Well, everyone does use it. Okay, that's the list of logos from the Git website. You guys have already said you use it, so that's fantastic. There are lots of good reasons for using it, which I'll talk about in a little while. But can you use it for your geospatial data? Yes, you can, but it won't do a very good job because Git knows about things that look like text files and things that look like lines of text in text files, and it knows about how to deal with conflicts and compare things that look like text. Now, that doesn't really work for geospatial features, where you need to know about geometries and whether things are overlapping. So there isn't an immediately obvious way of making it do that. So it would be a good idea to have that. Okay, I've got a couple more slides on Git, so bear with me. Quick reminder, what's so good about Git? The Git website tells us, so I copied their image. It does branching and merging very well, very cheaply. It's small and fast. It's distributed, so if you like, you don't have to have a single master in the center of it. You can have your Git repositories distributed as you please. There's kind of data assurance baked into it, so you know the data you put into Git is the data you'll get out, because that's kind of fundamentally built into the way that it deals with files. It has this staging area concept to it, which means that you always kind of get to see the data arranged before you then push it up into the repository. And of course, it's free and open source. Oh, there's GitHub as well, but it's important to remember that GitHub and Git are not the same thing. So GitHub is kind of a really, really good system that uses Git. Okay, so you get these fantastic workflows, which I'm sure you're all familiar with, where you're encouraged to branch often because it's cheap and it's a great way of dealing with things. And you can come up with a wonderful Git branching model that suits your needs. And this is one of the interesting things about Git, of course, is it doesn't impose any kind of regime like this on you. It's up to you to design or pick a way of using Git that fits in with your workflow, the things you need to do. It doesn't give it to you on a plate, just gives you the power. Okay, then there's GeoGig. So, having said that Git's a really nice way of dealing with your code, it would be a wonderful way of dealing with your geospatial data. So some clever people, and they're from lots of different places. You can go and look through the history in the Git repository if you want to find out more. Got together and produced GeoGig, and it's an open source tool that draws its inspiration from Git, but adapts the core concepts for geospatial. That's why it's not called GeoGit, by the way, is because it isn't Git in the middle. The guys who wrote Git didn't write GeoGig, so a different name was chosen. I think they've actually got some sort of copyright protection on the term Git. So GeoGig is the name that's been chosen. So you can track your spatial edits, and it supports lots and lots of the formats and forms of holding the data that you'll be used to. And you can track all those changes, and you can do those Git-style things to the data once it's been tracked in that way. It's written in Java, it's available under the Eclipse license, and it's all good. Not surprisingly, GeoGig is on GitHub. It'd be weird if it wasn't, right? So you can go and take a look. There's some really good instructions and documentation on there. If you like, you can download some pre-built software and get that working. I've had it working on Windows and Linux and Mac. It seems to just work fine. There's good instructions on there, but if you want to, you can check out the source code from GitHub and build it yourself. And that means if you want to, you could build a dev branch and try out some of the new features or some of the other branches to see what you want to do. And in fact, that's all I've done with my work on GeoGig. Just read the documentation that's there. I haven't had any extra help. It's pretty good. Everything you need is pretty much there. Once you've got your install done, you can use GeoGig on the command line just like you would Git. Remember, though, there isn't a kind of GitHub helper over the top, so it's back to using Git as you would have done before GitHub was around. So having said it's very similar, there are some differences, and one of the most important ones I've tried to explain in this slide. So I hope I'll do this justice, and if any of the GeoGig contributors want to chip in, then feel free. Okay, so one of the differences is that unlike with Git, where all of your data and the revisions are held within a kind of file structure in one place, with GeoGig, that's split in two. So there's what's called a repository store, where GeoGig keeps all of its information about the data and the changes to the data. But your spatial data itself, you keep in the format that you're most used to keeping it in. So that could be a PostGIS database, a shapefile, GeoJSON file, and loads of other different formats are supported. The repository, the earlier versions of GeoGig used BarclayDB for the repository, and I think still the current version does actually. But because of licensing problems with BarclayDB, they're moving to using SQLite or Postgres for that repository storage, which means it can be quite interesting. So in a lot of the tests I've done, I've been using Postgres for the repository store and Postgres again with PostGIS for the spatial store, but it's two separate databases doing two different jobs. And in fact, the repository store database doesn't use the GIS extension, so it's a non-geospatial database. It's being used to track those changes. Okay, so that's a difference, and that does slightly change the workflow when you're dealing with data. Okay, so to use GeoGig, it's very similar to Git. First of all, you create yourself a repository, and you throw in some data from one of the supported formats. You then add the data to your staging area, and then you can do a commit to push it into the repository. You can invite some friends to do the same. They can do their import, adding, and committing. And so it can be more complicated. Important thing here is, just like with Git, you need to agree what the strategy is going to be around branching and merging and all the rest of it. You need to have an approach sorted out for doing that. GeoGig doesn't help you any more or less than Git does in that respect. So I'm going to flip to the command line now in a risky move and just check in some data that I've got kicking about. If you don't like command line demos, then you'll hate this. Right. Okay. There we go. Right. Got a cheat sheet for this. Okay, so just like with Git, the first thing you'll probably do is set yourself. Right. Can everyone see this? Okay. I'll put the font size up. So the first thing you probably have to do is, it's the first time you've initiated any GeoGig repository in your system, is you want to set your username and email address. Okay, just like in Git, you can do that globally or you can do it on a particular repository. I've already done that, but if you want to do that, it's the same sort of syntax as Git. So you do GeoGig -- and global if you like, and then user.name equals Joe, whatever you want to do. So I'll skip that bit for now because this is already quite painful. GeoGig init will initialize your GeoGig repository in the directory that you're in. Okay. Right, I'm going to just do something else a second. Yeah, I'm going to just create a directory to put the repository in and then go in there. So, okay. Too nervous to type. Right, so I will then initiate my repo in here. Ooh. Okay. Let's try that. I knew this demo would go well. Yeah, okay. See, you're learning as I'm doing this, I'm sure. It's fine. Right, let's try again. Fingers crossed. Yay, there we go. Okay. God, that was painful. So I've initialized a GeoGig repository here. Now I need to feed some data in. Now I'm going to use some data I've already prepared and put into a PostGIS database. I'm using some of Ordnance Survey's data that's quite nice for this because it shows the Olympic 2012 site, and there's lots of interesting buildings that came and went for the 2012 Olympics. And I can show you some pictures of that in a minute in QGIS, but for now it's just a command line, I'm afraid. I want to get a bit low on the screen there, aren't we? Okay, so I'll just quickly have a look inside my database. Ooh, nice. Okay, so these tables here, Topo 2011, 2012, 2013, 2014, 2015, they're the interesting data. So to load data out of a PostGIS database, it's fairly straightforward. So you type, where are we? GeoGig PG for PostGIS, import. I'm going to run out of screen really quickly, aren't I? You can then set what you want to use for the unique feature ID. Okay, and I've got a feature ID called FID already in that data set, so that makes things easier. And I need to set my database name, which is Topo 2011. And then just a couple of other little bits. Set the Postgres user and the table name. Does that look okay? Yay, right. So you get some warnings. They're only warnings, don't worry. Then it goes through and it's found 148,683 features in that data set, and they are now imported. So if I do a GeoGig status, just like with Git, it should show me that I have loads of stuff waiting to go into this staging area. So I can then do a GeoGig. If I'm happy with that, I can do a GeoGig add topographic area. And I'll add those in. If I do another GeoGig status, so you can see they're added. And then I can do a GeoGig commit with a commit message. Always use a useful commit message. So added topo area data from 2011. Okay, we've got some data in our repository. So if I do a GeoGig log, it should show us the list of the commits made to our repository. And there's one commit made by me 8 seconds ago. Okay, I'm going to commit one more set just so you can see a change, and I'll quit doing that, and we'll have a look at the results. Okay, so I will use the history here to import the 2012 table. So you get some warnings. And then it will crunch through the data. Should give us a summary. So there were 31,000 features inserted, which is cool. Again, I'll do a GeoGig status because this time, rather than just added features, you'll see that GeoGig has been through the data, used the FID that I specified, and it's able to tell where a feature's been removed, modified, or added, and give us that nice summary, just like if you were dealing with code. Okay, so I need to Where did I get to? I probably need to do an ad, don't I? Yeah. Topographic area. Yeah, and then I can do another commit message, which is going to look remarkably similar. No, must try and be useful with my commit message. So I'll change that to updated because it wasn't just an ad this time, was it? Yeah, okay. Right, so there were 12,000. Yeah, you see the summary there of what changed in that data set in the Git style. So that's fine, and you can do that for hours, if you like, adding more data, which I won't, thank goodness. So that's great, and you see the data's gone in there. You can use the usual kind of commands that you're used to in Git. So if I want to do a diff summary, hang on, I need to reference. Yeah, no differences found because I'm up to date. But if I do a GeoGig log, I can look at the commit list again, and then I can I can say what's the difference between now and the commit tag with 59116 CD24. No, I'm not typing the whole thing, don't worry. Hang on. Yeah, I got it. Hey, look at that. So there's a lot of exciting changes there. And if I get rid of the summary, yeah, there we go. So while that's whizzing past, you notice in there there's geometry changes which are shown in WK, something relevant. Also, you'll see the attribute changes as well. So lots of version changes from one number to a higher number. All of our polygons in this data set have an area attribute attached to them, so you see that changing quite a lot as well. So it's tracking all that nicely. I'll have to Control C this because it's going to go on for about a week. Okay. Right, did everyone enjoy that command line based demo? Yeah. I thought I'll be all right as long as it's green. Okay. Right, so let's get back to, okay, how am I doing for time? So getting back to the presentations then. So I typed in lots of commands. It doesn't look that good on screen, does it? But generally that's how you do these things in real life, isn't it? But there is a GeoGig plugin for QGIS which makes for a better demo. Why didn't I use that from the beginning? So it's there, and I'll switch over to QGIS in a minute. There's lots of tutorials for that as well. The QGIS plugin isn't as robust, I have to say, as GeoGig itself, and I've had quite a lot of problems with it, especially today. But I think that's mainly because I went and moved on to a newer version of QGIS, and I don't think the plugin's kind of set up for it yet. So I shall do my best. We'll see how we get on. Right. So somewhere in my sea of virtual machines. Okay, so right, so that data we were looking at is actually comes from this part of London, which is where the 2012 Olympics were held in 2012, and it was an interesting place to look because lots of buildings suddenly appeared, as you would expect. Hang on, let's get this the right way around. We'll go forward in time rather than backwards. Yeah, okay, so this was the site before the building work started. I don't think I can make it much. I can make it a bit bigger than that, can't I? Okay, so this was the site before the building work started. Lots of railways and disused buildings. And then with the Olympics, lots and lots of building work happened. So in 2011, it looked like that, just a huge building site. As you can see there's a stadium starting to be built here. By 2012, well, I'll go through a few pictures here. So these are pictures taken from Ordnance Survey's plane. We had a special contract with the government to do lots and lots of surveying for the Olympic site because they needed really good data for the event, which is good because I got really good photos for this. But the interesting feature is this thing here. So this is the aquatic centre. This is where the Olympic swimming events took place. A nice feature about this building is it was built initially with these two big wings on the side. They're actually temporary structures that were for spectators to sit in. Once the Olympics were finished, those were removed so that it could be a normal kind of swimming facility.